Welcome to day 2 of stoichiometry. Today we're going to go from mass to mass. Yesterday we talked about the most important thing here is knowing your unknown and your known. Now I've not ever done this, used highlighters on this before, so I don't know how well this is going to work, so bear with me. So we're going to use, I guess, red for our known quantity. What is our known quantity in this first equation? Okay, we're told that we have 6 grams of nitrogen. So nitrogen is what we know. And we're solving for hydrogen. So hydrogen is our unknown. This time, though, we're going to start, instead of with moles, with mass. We know that we have 6 grams of nitrogen gas. How do I change grams to moles? I have to divide by the molar mass of nitrogen. Nitrogen is 28 grams in 1 mole. So if I take 6 divided by 28, I get 2, 1, 4, 3, putting some extra sig figs in there, moles of nitrogen. So now I've effectively gone from mass to moles. I have moles that are known of nitrogen. The next step is to multiply that by my ratio. If I look at my equation, 1 nitrogen will react with 3 hydrogens. Nitrogen is the known, so that goes on the bottom. And hydrogen is the unknown, so that goes on the top. Once I do that, I have 0.6429 moles of hydrogen. So now I've gone from known to unknown moles. However, it wants grams. So the last thing I have to do is take that number of moles, 6429 moles of hydrogen, and change that back to grams by multiplying by the molar mass of hydrogen, which we're going to go with just 2. And we end up with 1.286 grams. Now, sig figs. I have 2 sig figs in the equation, so my answer is going to be 1.3 grams of hydrogen. All right, the next one. My known is 6 grams of potassium chlorate. And I'm solving for grams of oxygen. Oops, that didn't change color. So, there we go. I'm going to start with 6 grams of potassium chlorate. The molar mass of potassium chlorate, I made a note over here on the right, it's 122.55 grams per mole. You'd have to look that up or calculate it. If I multiply that, divided, 0.04898 moles of KClO3. The next step is to multiply that by my ratio. My known quantity goes on the bottom. There are 2 moles of KClO3 for every 3 moles of oxygen. .07347 moles oxygen. I'm going to erase this so it's not getting in my way. And now I need to go back to grams because I need to find grams of oxygen. So I'm going to multiply by the molar mass of oxygen, which is 32 grams in 1 mole. I'm running out of space here. I'll put it up above. 2.35 grams of oxygen, which rounds to 2.4 grams once we do significant figures. Next one, how many grams of hydrogen? That's my unknown. That's what it's asking for. Are produced from the reaction of 3 grams of zinc. So we're going to start with 3 grams of zinc. The molar mass of zinc is 65.41 grams in 1 mole. That gives me 0.04586 moles of zinc. My ratio of zinc is 1 mole of zinc to 1 mole of hydrogen gas. And I multiply that by the molar mass of hydrogen, and I get 0.092 grams of hydrogen. Last but not least, my known is 4 grams of propane. My unknown is oxygen. Start with 4 grams of propane. The molar mass of propane I looked up, 44 grams in 1 mole. That's 0.090909. But I'm going to do something. Instead of hitting equals like I have in each of the above, instead of putting equals in, I'm just going to put my ratio in right next to it. My known is 1 mole of C3H8. My unknown is 3 moles of oxygen. That is going to give me moles of oxygen. So I've crossed over my bridge. Now I need to change that to grams. So I multiply it by 32 grams in 1 mole. And we get 8.7 grams of oxygen. All right. Hopefully that answers all your questions.